Subscribe now.
The 4-point ID of t, because we have already done the 4-point DFT. So for the 4-point ID of t, let's take the example that we solved earlier on. For instance, we have x of k to be equal to 2, 1 minus j, 0, and then 1 plus j. As I was saying earlier on, when you are doing the forward DFT, you can find the first three and the other one you don't have to calculate using complex conjugates. But now let's focus on the ID of t. Now that you have been given the x of k equal to 2, 1 minus j, 0, 1 plus j, let's find the ID of t of x of n using direct computation. So using direct computation, as I said, the formula is s of n is equal to 1 over n summation of k equal to 0, and then n minus 1 x of k exponent j 2 pi over n nk. So for this, the total number of elements is equal to 4, and therefore we cannot write it as x of n is equal to 1 over 4 summation of k equal to 0, and then n 4 minus 1 is 3, and then x of k, and then exponent, because it's 4, we are going to get j pi over 2 nk. So now that we have this, we can say that we are looking for all the 4 elements. So we are going to start from n is equal to 0, 1, 2, and 3, which is n minus 1. So based on these ones, for n equal to 0, we are going to get 1 over 4. Because n is 0, as usual, we are going to get x of 0, exponent 0, plus x of 1, exponent 1, 0, plus x of 2, exponent 0, plus x of 3, exponent 0. So in this case, the question is, the x of 1 is 2, and x of 2 is plus 1 minus j, the x of 2 is 0, and then the x of 3, it's 1 plus j. So minus j will cancel plus j, so this will go out. So now we are going to get 2 plus 1 plus 1, and don't forget it's 1 over 4. So for here we are going to get 1 over 4 multiplied by 4, which is equal to 1. Right, this is equal to 1. So for the first element. So for the second element, we can see that the second n equal to 1 is going to be the one that we are going to base on it to do the computation. So for n equal to 1, we have x of 1 equal to 1 over 4 exponent summation of k equal to 0 to 3 x of k, and then exponent j, right? And then we have pi on 2, right? Like the way we did here, pi on 2 nk, right? And then remember that n is 1, so you don't even have to write the n, you can just write it straight away. Okay, so from there, so for k equal to 0, 1, 2, 3, we are going to get x of 0. For k is equal to 0, we are going to get exponent 0. Don't forget it's 1 over 4 for the whole thing, plus x of 1. For k equal to 1, we are going to get j pi on 2, and then plus x of 2. For k equal to 2 is j pi multiplied by 2 over 2, of which the 2 here will cancel out, so we are going to get j pi, and then plus x of 3, of which we are going to get j 3 pi on 2. So based on this, we need to do the simplification. So when we are doing the simplification for this analysis for n equal to 1, we are going to get something like 1 over 4 multiplying by 2, because automatically the first part is 2, which is the question. This is it, right? And then the second part is plus j, right, plus 1. That's x of 1. And then plus 0 minus j, or let me simplify it straight away from here so that you will not be confused. So it can be like x of 0 this one will give us 1 plus x of 1, and this particular one will give us j multiplied by j plus x of 2, and this particular one will give us minus 1, right? And then plus x of 3, and this particular one will give us what? Minus j. This is it. So based on this one, we can simplify it as 1 over 4. When we put the coefficients of x0, x1, x2 inside, we are going to get 2 plus j plus 1 plus 0 plus j plus 1, which is going to equal to 1 over 4 multiplied by the j goes with the j, and we are going to get 4 here, and at the end of the day we are going to get 1. But let's look at the other side as well. For n equal to 2, we are going to also get 1 over 4 exponent k equal to 0 to 3 x of k, and then exponent j pi over 2, and let's say it's 2, so 2k, and then 2 will cancel this one. So now we are going to get 1 over 4 summation of k equal to 0 to 3 x of k, and then we are going to get exponent j, and then whatever we are going to, j is pi k. So now that we have this, for n or k equal to 0, 1, 2, 3, we have to insert them inside. We are going to get 1 over 4 into brackets x of 0 exponent 0, because when k is 0, everything goes 0, plus when k is 1, we are going to get x of 1, right, exponent. When k is 1 here, we are going to get j pi, and then when k is 2, we are going to get x of 2 exponent what? J 2 pi, plus when k is 3, we are going to get x of 3 exponent j 3 pi. So based on this, we are going to get something like 1 over 4 multiplying by x of 0 and then 1 plus maybe x of 1. When we simplify this, we are going to get negative 1 plus x of 2. When we simplify the exponent j 2 pi, we are going to get 1, and then when we simplify exponent j 3 pi, which is x of 3, and that we are going to get negative 1. So in doing this whole simplification, we are going to get 1 over 4, right, multiplying by let's say 2 multiplied by 1 plus 1 minus j multiplied by negative 1 plus 0, right, that's what is 0 multiplied by 1 plus another one is 1 plus j multiplied by negative 1. So based on this, we can see that we're going to get 1 over 4 multiplied by 2 minus 1 plus j plus 0 minus 1 minus j. At the end of the day, we are going to get 1 over 4 multiplied by this j cancel j, and then that j cancelling j. Remember that here it's plus 1, right? So the being plus 1 here, the 1 will go here, and then what the 1, let's say negative 1, sorry, let me so it's 2 minus 1 plus j plus 0 minus 1 minus j. J will cancel j, minus 1 minus 1 is minus 2. The 2 is 2 here, so we are going to get 0, and then 0 equal to what? 0. And then for the last part, that we are doing here, for n equal to 3, we are going to get x of 3 equal to 1 over 4 exponent summation of k equal to 0, and then 3 x of k exponent j pi on 2 k j pi on 2, and then n is 3, so 3k, right? And then for them, we can also rewrite it as 1 over 4 summation of k to go to 0 to 3, and x of k exponent j 3 pi on 2k. For k equal to, or let's say k equal to 0, 1, 2, 3. For 0, we are going to get x of 0 exponent 0 plus x of 1 exponent 0 plus x of 2 exponent 0 plus x of 3 exponent 0. So for k equal to 0, we are going to get x of 0 exponent 0 plus k equal to 1, we are going to get x of 1 exponent j 3 pi on 2 plus x of 2, this is going to be exponent j 3 pi plus x of 3, we are going to get exponent j, 3 times 3 is what, 6 pi on 2, and then when we divide it, basically we are going to get, so j 9 pi on 2. And remember that they are all 1 over 4. So based on this, we are going to get 1 over 4 multiplied by 2 plus 1 minus j, because when you simplify it, it's minus j, and then plus 0 plus 1 plus j, and when we simplify this, it's what, j. So based on this, we are going to get 1 over 4 to be 2 minus j minus 1 plus 0 plus j minus 1. And at the end of the day, we are going to get this one, we'll cancel this one. So we get negative 2 and then plus 2. Then we're going to get 0 here. So we are going to get 1 over 4, 0, which is equal to 0. Now that we have it, we can see that our first computation, we got 1. Our second computation, we got 1. Our third computation, we got 0. And our fourth computation, we got 0. And therefore, we can say that our x of n is equal to what? 1, 1, 0, 0. So you can see that this answer, it's similar to one of the questions that we solved up there. This is one of the questions that we solved. And then it's true, j0 and code 0. So basically, we solved that question. This is one part that we got. And there was another part as well. And then some other parts. And I believe that this is what we are supposed to get back. So if you do this, we are supposed to get the discrete Fourier transform that we calculated, which is this. So this is where I'll end for today's tutorial. Please, I have additional questions for you for trial. I'd like you to do this on your own. So this is a trial question. Try x of k to be equal to 0, 0, 0, 2. And the answer that you are supposed to get is supposed to be 1, negative 1, 1, negative 1. And then 2, x of k, you can also take a look at it. We are going to get 4, 0, 0, 0. So compute using direct computation, and the answer that you are supposed to get is supposed to be s of n equal to 1, 1, 1, 1. So thank you for watching, and see you in my next tutorial.